The key thing to understand is that when people drink, the prefrontal cortex and top-down inhibition is diminished. That is, habitual behavior and impulsive behavior starts to increase. Now, what's interesting is this is true in the short term, so after people have 1 or 2, maybe 3 or 4 drinks, but it's also true that the more often that people drink, there are changes in the very circuits that underlie habitual and impulsive behavior. Okay, this is really important to highlight, so much so that I want to drill into it a little bit more deeply. For the person that drinks, say, every Thursday night or every Friday night, or goes out only on Saturdays but every Saturday, there's evidence that there are changes in the neural circuits of the brain that control habitual behavior and impulsive behavior, and they are modified and strengthened in ways that make those people more habitual and more impulsive outside the times in which they are drinking. And when they drink, impulsive and habitual behavior tends to increase even further. This is something that's not often talked about when discussing the effects of alcohol. I mean, we all know the effects of being drunk can be bad, right? Can be bad in terms of judgment, motor coordination. Certainly driving drunk is a terrible thing, get you or other people killed, and so on. But rarely do we hear about the changes in neural circuits from just 1 or 2 nights of regular drinking. Again, chronic drinking doesn't necessarily mean every day and every night. It could be the person that simply drinks every Thursday or every Friday, or just once a week has 3 or 4 drinks, or maybe even a few more. That person is going to experience a decrease in this top-down inhibition, so an increase in impulsivity and habitual behavior because the brake on those behaviors has been removed while they're drinking, but also changes in the very neural circuits that allow habitual and impulsive behavior to occur more readily even when they're not drinking. And if you want to know the actual substrate for that, the cellular substrate, I can briefly describe it. It's really interesting. Again, you don't need to know any biology to understand this. What it does is it increases the number of synapses, the actual points of connection in the neural circuits that control habitual behavior. So there's literally a growth of the neural circuits in your brain that lead to existing habit execution, right? The performance of things you already know how to do, and a reduction in the neural circuits, or I should say a reduction in the number of synapses of the contacts within the neural circuits that are controlling behavior. So this, again, is a not often discussed aspect of alcohol intake. Fortunately, it is reversible. So in animals or humans that undertake a period of abstinence of anywhere from 2 to 6 months, these neural circuits return to normal, except in cases where people have been chronically drinking large volumes of alcohol for many, many years. And in those cases, while there is some recovery of brain circuitry after people get sober, meaning completely sober, they stop drinking entirely, there is evidence of long-lasting impact of heavy alcohol usage throughout the lifespan. But of course, this doesn't mean that anyone that's suffering from alcoholism or that used to should not continue to focus on their health. You absolutely should. All is not lost. But for people that have been drinking for a lot of years, maybe you went to college and you drank a lot in those years and your neural circuits change. If there's a period in which you don't drink alcohol, again, from 2 to 6 months and ideally longer, those neural circuits can then be remodified back to their original state. So let's consider some of the other neurochemical effects of alcohol on the brain and body. And again, for right now, we're confining the conversation to people that are drinking on average 1 or 2 drinks per night. Now, some people might think that 2 drinks per night is a lot, and a lot of that will depend on body weight. So for instance, people who weigh 110 pounds, for them to ingest 2 alcoholic drinks is going to be substantially different in terms of the biochemical effects than somebody who weighs 220 pounds. Of course, tolerance will also factor into this. Genetic background will also factor into this. And indeed, whether or not people have eaten will factor into this. So there are a lot of factors, and we'll talk about that. For the time being, if you're curious about how food impacts the effects of alcohol and your feelings of being drunk, you may have heard, for instance, that if somebody's inebriated and they want to sober up, they should eat something. Turns out that does not work. Here's how it does work, however. If you eat something prior to drinking alcohol or while ingesting alcohol, it will slow the absorption of alcohol into the bloodstream. In other words, you won't feel as drunk as fast. For many of you, this probably comes as no surprise. In particular, if that meal includes carbohydrates, fats, and proteins. Okay, the inclusion of all 3 major macronutrients seems to slow the absorption of alcohol into the bloodstream far more than having any one of those or 2 of those macronutrients present. Now, if you are already inebriated or you've had a glass of wine or a beer and you eat something, chances are that alcohol has already made it into your bloodstream because it moves into the bloodstream so quickly. Again, it's fat soluble and water soluble. So within minutes, right? If you have an empty stomach, within 5 to 10 minutes, that alcohol is going to be within your bloodstream and distributed throughout your body, maybe even faster depending on the type of alcohol and your metabolism. But if you're already drunk and you eat something, it's not going to sober you up more quickly, but it certainly will blunt the effects of any additional alcohol that you might consume. And if you're somebody who is concerned about getting too drunk too quick, even from a small amount of alcohol, having some food in your gut can certainly be beneficial. Now, that's food and alcohol and the absorption of alcohol. But let's go back to talking about the biochemical and neurochemical effects of alcohol on the brain. We talked about top-down inhibition, and we talked about habitual and impulsive behavior circuitry. There are also dramatic changes in the activity of neurons that control the release of so-called serotonin. Serotonin is a neuromodulator. It changes the activity of neural circuits, and many neural circuits, in particular those involved in mood and feelings of well-being. Recently, there's been a lot of interest in serotonin because of a study that was released that showed pretty conclusively that serotonin levels can't really explain depression and depression-like symptoms. I want to make it very clear that although that study did show that serotonin levels are not necessarily associated with depression, the study was interpreted by many to mean that SSRIs, selective serotonin reuptake inhibitors, which have the net effect of increasing serotonin, so these are things like Prozac, et cetera, that those drugs are somehow not helpful because they increase serotonin and serotonin isn't involved in depression. That logic doesn't really hold together, so I'm going to use this as an opportunity to just clarify what really occurred there, and then we'll talk about how serotonin relates to alcohol consumption in things like feeling good and in depression. The key thing is this: SSRIs can help alleviate depression. That's right, SSRIs can help alleviate depression. They are often, not always, associated with side effects. Dosage is very important, et cetera. But they probably support relief from depression by changing neural circuits, not necessarily by increasing serotonin itself. That is, increasing serotonin with these drugs likely change the neural circuits involved in mood, allowing people to feel better through so-called neuroplasticity, which is the brain's ability to change itself in response to experience. So there's a bit of confusion. And again, I'm using this episode on alcohol to highlight some of the confusion because I think it's timely, because the study just came out and there's a lot of chatter about this out there, that when people are depressed, it's not necessarily because serotonin levels are low. However, if serotonin levels are increased with things like Prozac, Zoloft, and other SSRIs, oftentimes there is, yes, a relief from depression, but that's probably not because of restoring serotonin levels per se. It's probably because serotonin facilitates the changes in neural circuits that need to occur in order for people to feel elevated mood. Okay? So again, that's a bit of a tangent and aside, but I do think it's a vital one for people to know about. Again, if you're thinking about taking SSRIs, you're currently taking them and you've heard this news, definitely talk to your doctor. Again, there is great utility for some of these SSRIs, and also in conditions like OCD, they've been shown to be very beneficial. So we really don't want to throw SSRIs out as a potentially valuable treatment. Getting back to the effects of alcohol on serotonin, it's very clear, beyond any doubt, that many of the circuits in the brain that are involved in mood and feelings of well-being, and also sort of self-image and how we see ourselves, employ the neuromodulator serotonin. And alcohol, when we ingest it, and it's converted into acetaldehyde, it goes and that acetaldehyde acts as a toxin at the very synapses, the connections between the serotonergic neurons and lots of other neurons. In other words, when we ingest alcohol, the toxic effects of alcohol disrupt those mood circuitries, at first making them hyperactive. That's right, making them hyperactive. This is why people become really talkative. People start to feel really good after a few sips of alcohol, at least most people do. And then as they ingest more alcohol, or as that alcohol wears off, serotonin levels and the activity of those circuits really starts to drop. And that's why people feel less good. And typically what they do, they go and get another drink and they attempt to kind of restore that feeling of well-being and mood. Now, typically what happens is that as people ingest the third and fourth, maybe even the fifth drink, there's an absolute zero chance of them recovering that energized mood, right? Most people, as they drink more and more, will now start to feel more and more suppressed. The forebrain is now shutting down quite a lot. A lot of the motor cortical areas that control coordinated movement and deliberate movement start to shut down. So people start to slur their speech. People start to shuffle their feet. People forget their posture. People start to lean on things. People start passing out on couches. There's a great depression, not depression of the psychiatric depression sort, but a depression of alertness and arousal, and eventually people will pass out. Now, I said most people because there's a subset of people that have gene variants or who are chronic drinkers or who are chronic drinkers and have gene variants that as they ingest the third and fourth and fifth drink, what happens? They become more alert. They start talking more. They feel great. They have all sorts of ideas about the fun they could have that night. And they're the ones that if you've ever fallen asleep at a party for whatever reason, or you're getting tired and you're yawning, you're looking around the room and like these people are still drinking and partying and they're having what seems to be this amazing time. Often, not always, those are the future alcoholics in the room, or those are the people that have a genetic predisposition for alcoholism, or those are the chronic drinkers, the people who have built up enough of a tolerance or who have the chemical genetic makeup such that increasing amounts of alcohol make them feel better and better and better. And of course, they too have a threshold beyond which their nervous system will start to get diminished and they'll pass out and fall over, etc. But that threshold is way, way higher than it is for most people. Now, this is important to understand, and it's important to understand because I think everyone should know and recognize their own predisposition and kind of risk in terms of developing alcoholism. It's also important to understand because it relates to the phenomenon of blackout. You know, many people think that blacking out is passing out, but blackout drunk is when people drink and they're talking and doing things. Sometimes, sadly, or tragically, they'll often drive home or walk home, or they'll hop on a bicycle and ride home, or they'll go swimming in the ocean. All, of course, very dangerous activities to do when people are really drunk, or even a little bit drunk in some cases. So these people will do these sorts of things, and they do them because they have the energy to do them, and they feel good while doing them, but they are doing them while the activity of neurons in the hippocampus, which is involved in memory formation, are completely shut off. And this is why the next day you tell them, hey, maybe we should talk about what happened last night. I'm like, what happened last night? He said, well, do you remember going to the party? Yeah, no, it was great. We did this, and then what? And it's very clear all of a sudden that they have no recollection of all the things they were doing despite being awake.